So let's find the electric potential. Notice I did not say energy. It is the electric potential itself. It is V. I'm looking for the electric potential. Notice I'm not saying electric potential of a system. I'm looking for the electric potential. It has to be at a particular location. So if I have, let's say, charges on the corners of a square, let's make this 3 microcoulomb, negative 3 microcoulomb, 4 microcoulomb, and 5 microcoulomb. What is the electric potential, let's say, here in the middle? Now, if you recall, the formula for the electric potential is equal to kq over r plus some constant. So to deal with the constant, we need to define a value, usually where potential is equal to 0. So if the potential is equal to 0 at, I guess, 0 volts, at r is equal to infinity, meters or whatever distance, unit distance you want to use, then this would come into C being equal to 0. And so we're just going to be using that. Now, technically, I could make a definition here so that it's equal to 0 at this point, because it's 0 wherever I want it to, because ultimately what's important is the change in potential, not the actual value itself. Same with potential energy. What's really important is the change in potential energy when doing analyses. But this is a common practice, and so I'll sort of get you used to it, but do recognize I have asked questions where this is not the case. So if I want to find it at this point, I guess if it's the corners of a square, you need to have some length here. So let's just make this 0.02 meters. And so I need to know what that distance is from here to here. This is the value of r. It's a square, so it should be the same for all of them. So this is 0.01, this is 0.01, 0.01, this would be 0.01 square root of 2, or 0.0141 meters. And so my potential in the middle is just the sum of them. And so this becomes kq1 over r1 plus kq2 over r2 plus kq3 over r3 plus kq4 over r4. All my r's are the same in this particular case. K's are the same, so I can just factor that out. So I get k over r, where this, so r is 0.01 times the square root of 2. K is 9 times 10 to the 9th. And then it's just going to end up being q1 plus q2 plus q3 plus q4. And so those cancel out, so that this is 9 times 10 to the negative 6th. And we get 5727565, rounding off, volts. And so finding the electric potential at specific point from point charges.